Hi, my name is David Heeman, and I'm with Creation Crate. Today we are going to learn about some basic electronics and build a basic circuit. This is some information that is useful when you are building some of your Creation Crate projects. First of all, every circuit starts with a power source. I have a couple of them here, and power sources can be something like a battery that you're familiar with, like these AA batteries, for example. This is DC power. Okay, so this is what we call a direct current. And then the power that's coming out of your wall, for example, is AC, which is alternating current. Now, for our purposes, we're going to be focusing on DC power. Okay, we're going to be using direct currents, like batteries, for all of the projects. We won't use really any AC power. This AA battery, if you look at it, okay, right here, does say 1.5 volts. So each of these will generate 1.5 volts. I also have this 9-volt battery, and yes, that's where it gets its name. It's 9 volts. I have a little button cell battery here, and this button cell battery will actually, you can see right on it, says 3 volts. This little tiny thing actually generates 3 volts. And then something like this, power source that you use to charge up your cell phone, for example. And this gives 5 volts. It's very important to understand how many volts you have, how many volts the components that you're trying to power will need. Something to be very aware of. Alternating current, like out of your wall socket, can be very dangerous. Any kind of current, any electricity can be very dangerous, and in fact it can kill you. As little as 100 milliamps can actually stop your heart. Well, then why, if I go like this, doesn't this battery stop my heart? Well, there's a couple of reasons. First is that there's a lot of resistance in my skin, and it doesn't allow that current to flow through. Second, and probably more importantly, is that these are very low amperage. So in order to calculate the power that is generated by your power source, which is in watts, you need to know what the current is. The current is in amps, and then you also need to know what the voltage is. So we know what the voltage is here, and these are very low amperage. But let me give you an example. If I take these two AA batteries that are 1.5 volts each, and I put them in series, which means I connect the positive to the negative like this, like you would if you're putting a couple of batteries in one of your electronic gadgets, right? And I put these together. This battery series right now is going to generate 1.5 plus 1.5 equals 3 volts. If I put 4 of them in a pack like this, I get 6 volts. Then if I expanded this and I put 8 of them in here, I would have 12 volts. Now the battery in your car also has 12 volts. It's much bigger. And if I took a wrench, and I do not recommend this, but if I took a metal wrench and I arced the positive to the negative side, I'd be in some serious trouble. And what would happen is, at the minimum, it would probably burn me, and it could kill me easily. So why, if I have 12 volts on these AA batteries, which, by the way, won't start your car, and I have 12 volts in the car, why would that kill me and this won't? That's because of the amps. A car battery is going to have something like 850 or more amps times the 12 volts. So that power is going to be a lot more than if I just have these AA batteries. So it's important to understand power is measured in watts, and that is the current, which is measured in amps, times the voltage, which is measured in volts. So what we're going to do is I'm going to show you how to test the voltage on here. I'm going to turn it to DC volts. I'll see what it says. So I've got my AA. On the battery, it will tell you which is plus and which is minus, and on the AA, this little part that has the little nipple sticking out is your positive, and the flat part on the back is your negative. Black is generally negative, and red is positive. So I'm going to take my black lead here, put it on the back. I'm going to take my red, put it on the front, and I'll look at my multimeter, and I'm getting 1.64 volts. Battery's brand spanking new, so it's measuring a little bit high, and that's okay. On the other hand, I have this 3-volt button cell battery. The back here is negative. On the front, it does have a positive sign, so I'm going to put that there. And I'm getting just over 1 volt. that means that this guy's just about to die. Okay, so we have a power source. The next thing that we want is whatever we're powering, right? In our case, what we're going to do is we're going to power up an LED, a little LED light, okay? Take these other batteries out of the way, and we're going to use this 9-volt battery right now. And I'm going to go ahead and draw this circuit out at the same time. So a battery on a circuit diagram looks something like this. Okay. Okay, that's my little 9-volt battery. I'm going to take and try and power this LED. So in a very simple circuit, I will come around here. This is going to be, we'll label this as the positive side. I'm going to come down to my LED, my little light. Okay, so that is a basic circuit. Once I connect this LED to power, it should light up. Now, an LED is a light emitting diode. Okay. This LED is a light emitting diode. That's what it stands for. On your LED, what you'll notice is that there is a longer lead and a shorter lead. The longer lead is going to be the positive side, and the shorter lead is going to be the negative side. And it is important because if you try to run the current backwards, it will not light up. So if you put the positive on this side and the negative on this side, this will not light up. I need to make sure that the positive and negative are connected the correct way. On this 9-volt battery, the positive is the smaller side. I'm going to take this positive, longer side, line them up here, and in totally basic circuit, I'm going to go ahead and put these together like this, and let's see what happens. Wow, it flashed and blew. What just happened here? This LED is too small to take 9 volts. But how do we solve this problem? We're going to solve this problem by using something else that you'll get familiar with your Creation Crate projects, and that is a resistor. Okay, this is a little resistor. Okay, there's a couple of different ones here, and what you'll notice about these is that, so for example, this resistor has blue, gray, and red band on it. This resistor has two orange and a brown band on it. And what that is indicating is how much resistance that this will kind of choke the power, all right? Choke the current from going through. If you look at it if you look at power like like water flowing, okay? What you have is the volts would be the water pressure, okay? So I could have a garden hose that's at 100 psi, and I can also have a fire hose at 100 psi, and that's kind of like this scenario we had with the AA batteries that are 12 volts and a 12-volt battery. They have the same amount of pressure, but the amps, you can look at it like the volume of water coming out. So definitely my garden hose at 100 psi has much less water coming out of it than a fire hose at 100 psi. That's going to knock me down, just like the car battery might knock me down. If I have too much current, it's like restricting it. So they have variable resistors that you can adjust, and that's kind of like your faucet. So if I turn the faucet on just a little bit, I get a little bit of water flowing out of there, and if I open it wide, I get all of it. Well, a resistor is going to work kind of like your spigot. Let's go ahead and the resistance is measured using Ohm's Law. Each of these color bands that I mentioned earlier tell you how much resistance this one is designed to provide. You can look these up. We're not going to get into detail about it, but I do want to show you real quickly that we can measure this. And what I have here with my multimeter, I have my two leads, and when they're not touching, there is no circuit. There's no complete circuit here. This is broken, and that means it's infinite resistance. Nothing's happening, and it's going to read a 1 like this. However, if I put these two leads together, then in theory I should have 0 resistance. That current is allowed to flow straight through, but there's going to be a little bit of resistance in the metal and in the wire, so I'm going to get a really tiny reading. If I want to measure one of these resistors here, let's take this one, and this doesn't matter which side you put the positive or the negative on, and so I got to turn this over to 2000, and what I'm getting here with this guy is about 330 ohms of resistance. Let's try this one here. It has a different color band on it, and I'm getting 985 ohms of resistance. Let's try this one. It's a little bit bigger, you can see, than the one we just tested. See what it registers. And this one registers at 995. The color bands on these two are the exact same. So I have like a brown, black, red. They're both the same, so even though one's smaller and one's larger, they're actually providing the same amount of resistance. So what I want to do is I want to put a resistor in this circuit that we just designed. Redraw this. Okay. And instead, right here, I got my positive. Go here to my LED. And I'm going to put my resistor on the negative side. And the resistor just looks like this. Okay, this is going to be a little bit more complex of a circuit because I can't just hold the LED on it. I'm going to have to put this resistor somewhere in there. So what I'm going to do, instead of trying to hold all those joints together, I'm going to use something called a breadboard. A breadboard is used for prototyping, and it allows you to create all the circuits without having to make them permanent. These are jumper wires. These jumper wires will slide into those slots that are in here, and they allow you to create the circuit. And I'm going to show you how to do that right now. So check this out. This is a diagram of what a breadboard looks like. These two top rails, they go horizontal. So this is where I'm going to put my power. I have my negative and I have my positive, and as soon as I take power and jump it right into the breadboard, this whole rail will be negative, and then this whole rail will be positive. Everything below here, instead of running horizontal, it runs vertical. So all of these will be connected. So anything that I connect in these boxes is automatically going to connect. So if I run this positive power to this side, all 4 of these are going to have some positive current flowing through them. They do not, however, touch horizontally. So these go horizontal, these go vertical. And what we'll do right now is we'll go ahead and draw out this circuit diagram. First, I'm going to go ahead and draw my battery. Let's draw a little battery here. This will represent my 9 volt, and I have big side is my negative, my small side is my positive. So I'm going to run negative jumper right here. Okay. And then I'll take and run a positive wire right here. So now I have a negative here, a positive here. And these, of course, don't touch. Okay, the next thing that I'm going to need is my resistor. Let's go ahead and draw this resistor out. What I want to do is I want to have some resistance. Just pretend it's a little green wire. I want to have some resistance. Let me take that back. I'm going to go ahead and get some power right here. So I'm going to jump it onto this rail. So if I put a wire there, now this entire rail is going to have some positive power. And then what I'm going to do is I'll run a jumper wire from here to here. And now, because I get this negative, it's going to jump over to here, and then this whole section is going to be negative. I'm going to put a resistor in line, and drop like this. I put the resistor right here. It looks a little something like this, right? Okay. And it'll have its little color bands on it. Just make them red for now. I'll make one of them blue, what the heck. Okay, I have my resistor. And now I need to power the LED. So this is super easy. Let's make it a blue LED. And what I'll do is this whole rail has positive current flowing through it. So I'm going to start it here. And then I want to get my negative from the resistor. I'm going to end here. Put that in. And then we'll draw our little LED light. Something like that. And now it's going to light up. It's not going to blow up. So take a look at that. I have some positive current here. I jumped it onto this rail, so the LED is getting its positive current here. I have negative, it's on this rail, which runs all the way across. So I took and I jumped from here to here. And so now this whole row has negative. And then I jumped this resistor from here to here so that I could bring a negative current right here. And then got my LED. So the circuit goes from positive, runs through the LED, runs through the resistor, and then comes back around here. And that's my complete circuit. This is providing the resistance so this doesn't blow this time. Let's go ahead and make that in real life. I'm going to take my breadboard. This is actually a breadboard extension, a little different than what I drew. I don't have the positive and negative rails on the top, but we're going to make it work. Since I know all these are connected, we can make this work. All right, I'm going to need to give it some power. So I'm going to go ahead and put some positive here in row 1. Okay. Now all of row 1 here has positive, and then in row, let's say row 10, I'll put the negative. Okay. I'll take my resistor, just like we did in the diagram. I'm going to make it so my resistor jumps from 7 over to 10. Okay, so I've got my resistor. One of the leads is in row 10, the other is in row 7. So in order to power this up, first of all, remember my longer lead is positive. I want that to be on the positive side, and I'm going to have to run that all the way over to row 1. And put that in row 1. Okay. I'll run the other side into row 7, and look at that. It lights up, and it didn't blow up. So I have positive current running through here to 1, and it's flowing through my LED, which in row 7 I have a resistor. That resistor is allowing the current to flow through it to row 10, and row 10 has my negative, so that's coming back to the battery. Okay, this is staying lit, and I don't always want my light to stay on all the time. At home, I have a switch where I can turn my lights on and off. So let's go ahead and add a little bit of complexity, and we'll do the same thing. All right, we're going to draw this diagram of this circuit real quick. On the positive side, it's flowing straight through. So this was my LED, and I have the resistor that was hooked up to that. And what I did then is we put a switch in this circuit. And what the switch is actually doing is it's just interrupting the circuit. So instead of the wires being connected all the time, sometimes, and in this case when we push the button down, we broke the circuit. So instead of these wires touching, they're no longer touching. So now that current can't flow through the circuit, and it turns the light off. And then when I let go of that button, it comes back, and the current is allowed to flow through. With our breadboard, what I'm going to do is I'm going to take this negative power out of 10, and I'll move it over to 15, because I want to add a switch in this circuit. I have a couple of switches here. This is an on-off switch. It's called a single pole, single throw switch. When I click it, it stays on. When I click it again, it turns off. So this switch is good for keeping something on and off. I don't have any leads on this one, so we're going to use this guy right here. This one is called a momentary switch. So that means when I depress it, it stays on, and then when I let go, it turns off. Or vice versa. This one's actually opposite, so you'll see how this one works in just a second. What I'm going to do, though, is I need to now connect this resistor over to this negative lead. Now, the resistor, you can put the resistor on the positive side or the negative side. It's going to work. You can also put a switch on the positive side or the negative side, because essentially what it's going to do is it's either going to complete the circuit or break the circuit. So let's see. I'm going to put this in row 10. That is the same row that one of my leads of my resistor is in. I'm going to put this in row 15. That's where my power is at. Okay. So now it is lit up, but if I push the button, it's going to turn off. So now I have a way to break the circuit and complete the circuit, turn my light on and off. Simple enough, right? And I happen to have a mini version of one of the Creation Crate projects right here. Let's take this diagram away. As you can see, what we've done is we've actually hooked up, this is a little buzzer, little piezo speaker, so it'll make different sounds. We have a couple of switches, a couple buttons here. We have some LEDs, and we have a bunch of jumper wires, which the simple instructions that Creation Crate has will show you exactly how to do all of this. And this is actually hooked up to an Arduino. And I have some power running to this, so I'm going to actually use this 5-volt power source. And as soon as I turn it on, what's going to happen is the Arduino is going to turn on, and the program that we loaded onto it, which you will also learn, and we will have a tutorial on the basics of the Arduino microcontroller. That is going to be in another video. So with this, I'm going to power it on, and as soon as I do, it's going to start running a program. Okay. This program is designed to play a game. It's a memory game. So the yellow LED just turned on. So this completed a circuit and told it to turn this on for just half a second or so. And the yellow light turned on. And it's waiting for me to follow the pattern. Now I got 2 yellows. Okay, it's going to keep letting me follow that pattern until I either do it right 10 times and then I level up, or I make a mistake. So I'll go ahead and I'll make a mistake, up, and I'll bust it. Okay, so with Creation Crate, you will learn to make these kinds of circuits. You will learn to do some computer programming using the Arduino microcontroller, and you'll get to make really cool projects like this memory game. You'll find information about the kits and other projects that Creation Crate has, and even other information and tutorials on their website, and that is www.creationcrate.com. I hope this was helpful, and if you have any questions, you can put them in the comments, and we'll try and answer them. Thank you.